my screen and we can get started. So if you remember from last week, we talked about classes, Python classes to be specific, and we learned how to make them and just looked at some really simple classes to start out with. And for review, I want to do a little bit more in depth and actually just go over what we talked about. And so I have these first couple, I think 3 slides that just go over what we talked about last week. So we can all be on the same page because we're going to learn a little bit more advanced stuff with classes today. So to begin off with the definition, right? This is not a formal definition, but the way you think about classes is that they're a blueprint. And they're a blueprint on how to make objects. Because Python, like other languages, is an object-oriented programming language. The language is all based on objects. You create objects, you tell objects to do things, and that's how your program works, right? When you create a string is an object. When you create an integer is an object. When you create a list is an object. All these things that you've been working with in Python are objects. Classes, all they are is just a collection of properties and methods. And so properties, they're just a fancy way of saying variables, right? Another term for this is fields. That's something I threw around, and that's my preferred term, fields. And the way I describe it is they're what a class has or knows, right? They're just bits and pieces of information that the class is able to store. Methods, on the other hand, that's just another name for functions. So we've seen Python functions before. That's one of the first things that we learned in Python level 2. And very simply, they're basically what the class can do, right? They perform some sort of task typically. And so classes, very simply, are just properties and methods bunched up together into one unit. And an object is just a specific instance of that class. And what I mean by that might be a little bit more easily demonstrated by like a real world example, not Python related, but we can think about cars, for example. So the idea of a car, the definition of a car is like the class, right? I have a screenshot of the Google definition, a 4-wheeled road vehicle that is powered by an engine and is able to carry a small number of people. Basically, what that does is it describes like a category of things. It says, okay, they're all similar in that they have these things, they operate in this way, right? It kind of organizes it into a group. It's the idea of a car, right? It's not a specific car, it's just the idea of what a car is. That's what the class is. On the other hand, the objects, what they are, they're specific cars. For example, a Tesla or a Ferrari or a Volkswagen, right? The car that you and your parents drive, right? That's a specific object, right? So you have like the idea, the more abstract thing, that's the class. And then the concrete specific car is the object. So I really want to make this clear, the class versus the object. And why this is important is because a lot of times we define the class, and that's very useful. But once you define the class, what do you need to do after that? Well, most of the time it's creating instances of the class, right? Because just like when you define a function, that by itself, it's good, but it doesn't do anything, right? You have to use the function before it does what you told it to do, right? Defining it by itself, if you run it, it doesn't really do much. The same thing with classes. You define the class and you run that and it won't really do anything. You have to define the class and then use it. And in this case, when I say use a class, that means create objects of that class. Diving deeper into this idea, this example of cars, bringing it a little bit closer to Python, I have a little bit of activity, and this will also serve as part of the review. But talking about this idea of classes as properties and methods, I want us to work together to brainstorm some ideas of properties and methods that this car class might have. So I started off let's look at properties first. Again, they're what the class has. And so, for example, you might have the color as a field of the class. And this might be stored as a string, right? Red, blue, green, black, whatever. You might also have the weight of the car stored. That would be probably a double or an integer if you want. Does anyone want to give examples of other properties or fields that this class might have, the car class? Let's check. Yep. So let's get maybe, yeah. Okay, Andrew says brand. That'd probably be stored as a string, but yep, that would be another field of this class. Let's get three properties. Model, yep. So similar to brand, but it is different. So like the Tesla Model T or the Tesla Model S or whatever. Yep, that's another good example of a property. Probably could be another string. Let's see, one more field. Size, yep. Could be like length, could be width. You can, other examples, you can have a speed, right? You can have like number of doors or number of occupants, right? Those are all examples of a field that the car class might have, because those are things that you might want to store and use for other things. You can also think of it, fields are oftentimes things that can differentiate different cars from each other, right? Because two different cars might have different weights, two different cars might have different brands, two different cars might have different colors. And so that's a field. It's like a property of the object. On the other side, we have the methods, things that the class can do. So this is an example, so you don't have to worry about like what it would mean in the code. But like in this case, methods would be like parking or braking, right? Those are things that the car does. Those are like actions. Can I get 3 other examples of methods for a car? Oh, I think, Andrew, I heard you unmute, but I couldn't hear your voice very clearly.
Wait, am I on mute?
Oh, maybe it wasn't Andrew. I definitely heard someone, but
Not me, I don't think so.
yeah, yeah. But I see in chat, Jonathan says drive. Yep, that's a good example. Cars drive, right? Any other methods? I'm looking for, let's get at least 2, but I prefer 3 or more. How about Jennifer? Can you think of any methods that our imaginary car class might have? Things that a car does. I see in chat, Jonathan said transport people. That could be a method, yeah. Like maybe maybe you'd have a method for like loading a person into the car. Maybe you have a method for letting a person out of the car. Other examples here, yep, Andrew, adding gas. Yeah, that's a great thing. And if we have a method for adding gas, we might have a field for keeping track of how much gas is in the tank, right? So that's like example of a field and a method working together. You can also have like turn left, turn right. You could have operate the windshield wipers. I know it was raining here, so that's why I was thinking about windshield. Turning lights, all sorts of changing gears, these are things that a car does. Those fall under the category of methods. So again, classes, they're like an idea of something. They're a blueprint. They have fields, they have methods. Fields are just pieces of information. Methods are functions, doing things. Okay. Once you have a class, once you have these properties and methods, you create specific objects. And these specific objects fill in the properties and they perform the methods, right? So like the class will define these fields: color, weight, size, how much gas it has, whatever. It defines all those things. It says those things exist, but they only get real values when you create a specific car, right? So you can say, oh, for the car class, I want to keep track of the color. But until you create an object, it doesn't really have a real value, right? It's just saying there will be a color. That's a field that I'm going to keep track of. But maybe you make a blue car, maybe you make a black car. You can make both of them. You can make 100 cars, all different colors, right? So the object is really important when we talk about classes, but they are separate things. I did have a couple more traditional review questions, which went a little bit beyond. We talked about the field and method, so I don't have to talk about that. But going to more of the Python, the actual coding. We mentioned that when we create these methods in our Python class, there's one parameter that is in every single method that we write. It's going to be the first one. And it's typically called something special. Like we have a name that we call it. Does anyone remember what this special parameter was for any method that we write in the class? Any function that we write will have this parameter. As a hint, it starts with an S, and it's a single word. Well, that was the special name for it, at least. It started with an S. Structure is a good guess. It's a bit longer than the actual answer. So like I said, technically, it's just a parameter. You could call it whatever you want, but our special name for it and the convention has 4 letters. Starts with S, has 4 letters. Maybe this gives it away, but the last letter is an F. So it starts with an S and ends with F. Does anyone remember what the special parameter was? Something like that. So yeah, 5 seconds, if anyone. Yep, thank you, Andrew. You remembered it's self. And so every single method that you have in the class is going to have this self as a parameter to the function. And what it's used for is to access the fields and methods of the class. And so you can think of it as going back to the car example. You create a specific car, like this Tesla, whatever. And maybe you have a method that fills up the gas. That method that fills up the gas, it's going to take in self as a parameter. And you're going to use that to do like self.gas tank plus 5 gallons of gas, something like that. Obviously, that's not real Python code. That's just pseudocode is what we call it. It's like fake code. But that's what you have that self for. You use it to access your fields, right? You imagine your add gas method will take a field and add some sort of amount to it, right? Because you're adding gas. And so that's a field that you need to access. You use it, you access it using that self keyword, that self parameter. And the other thing that was special about this self parameter is that it's automatically passed in. And so what I mean by that is when you create a object and call the method, you don't have to pass in that parameter yourself. It's done for you. And let me pull up the code that I had from last week, and hopefully that's a little bit more clear. So this is the notebook from last week. Here we go. So here's like one of the simple classes that I made. It has a couple of fields, has I, it has num, and it has name. And I have this function, myfunc. And you can see it has this parameter self, self. And inside the function, I can use it to access self.num, self.name. And what happens is I can create different objects, right? This is like creating the different cars. These are separate things. They have their own name, they have their own num, right? And so when I do like, oh, I don't do it here anymore, but I can do x.myfunc, like that. And what this does is this self thing over here, this mysterious self, becomes essentially x. So when I do self.num, what it's really doing at that point is doing like x.num. When I do self.name, what it's really doing is doing like x.name. And that's just because we're using x, our object, to call the function. If we used y.myfunc, then that self would now be y. If I did z.myfunc, that self thing would be z. Right? It's basically whatever object you're using to call the function. And that was the second review question. The last thing was talking about this special function. I'll give that part away. This really special function that every single class has, that's called something really unique. It's 2 underscores, right? These are 2 separate underscores. It's not just one. It's 2 underscores, a knit, and then 2 more underscores. That's the name of our special function. Does anyone remember what this is used for, or what we had called this? Like we had a nicer name for this special function. And it serves a very important purpose in a class. Does anyone remember? Yep, so constructor is the name for it. So based on the name, yep, Jonathan, assigns values, yep, that's what it does. That's kind of part of what it does. In general, it's what you use to create the object, right? When you write the class and you create objects, right? Python needs to know, how do I make objects of this class? And that's what the init function is telling you. It's, well, telling Python at least. It's telling Python, hey, I have this car class, this wonderful class, and here's how you create a car. It's this init function right here. And so when you go to make some cars, it's using that init function to do it. And what Jonathan, what you said is 100% correct. Typically what is inside the init function is assigning values. It could be taking in some parameters and then storing it into fields. That's very common. It might be doing some sort of calculation and then storing that. It might be doing something else entirely as well. Might be printing out messages, might be doing other things. You can put whatever you want inside the init function. It's just a function. But yes, typically assigning values is a very important part of the init function. All right. So that was the review. And I did want to clear up something that happened at the end of last class that I talked about really quickly, and I was confusing myself, and so I'm sure it was confusing you guys as well. But something I wanted to just talk about, which I think is kind of important, is these different fields in a class. And there's 2 different types of fields. There's static fields and there's non-static fields. And let's take a look. So here's another class that I created. It's also very, very simple. So I will paste it into the chat. And if we look at the class, let's step through this line by line. The first line is pretty basic. We're defining a class, so we need this CLASS class keyword, right? It's always the same. It's just like your def for functions. Then I have the name of the class very creatively. I just called it my class. You could call this whatever you want. You could call it ASDF, you could call it Bob, you could call it Jack. And then the first line of the class is defining one field, this field S. And I say it's an empty list. Then I have my constructor. This is the review. It's this underscore underscore init underscore underscore function. Notice it takes in the self as the first parameter because every single function has to take in self. And then it has another thing it takes in, a val, and it sets self.I equal to val. And so this self.I is another field. It's another property of this class. So we have two of them, S and I. Okay. And the second function in this class, all it does is, I think I might have paused, cut out for a second, but to recap the second method in the class, all it does is prints out the two fields, the two properties, S and I, right? So notice when I'm calling, like when I'm printing it out, I access it the same way, self.s, self.I, right? It's just self dot the name of the field. But there's a little bit of a difference in how they were created in the first place. For S, it was created outside of the constructor. It's just inside the class, not inside of any function. I, on the other hand, was defined in the constructor. And it was defined by saying self.I equals val. On the other hand, when we defined S, all we did is S equals the empty list. We didn't say self.S, right? So that's an important difference. And this is going to clue us in on how the two different fields behave. So I'll say it now, S is the static field, S for static, and I is the non-static field. I called it I because another term for non-static is instance. I can put the terms in chat, static versus instance. Right. And really quickly, I have it in the notes here, but static variables, static fields, they're shared among all objects, right? So you can create 100 objects of this class. They will share the same static fields. Instance variables, on the other hand, based on the name, you might guess, each instance has a different instance variable. It's unique for each object. And so let's take a look, right? Here, I'm creating two objects of my class, right? It's called my class, so I say my class here. And then I have to pass in this val, which is also an empty list, right? So I create my two classes, and right here, I can actually call the display method. So if I do a.display, you can see, oh, let's not do that, let's restart. So a.display, initially they're empty, right? Because that's what I defined them. S was defined as an empty, and I passed in an empty list for val, which is stored in I. So initially, S and I, they're both empty. I can also display for B, and like A, they're both empty as well, right? So we're starting off completely clean. Notice for the static variable, the one I defined this way, outside of any methods, I can take a look. It's still empty. I haven't changed anything yet. But this is a list. I can append some sort of value to it. I'm going to append the number 5 to it. Right? So I do that with this line. I have my object A. I access the field S. And then I append 5 to it because S is a list. And now if I display A and display B, what do you expect to see? Do you expect both A.S and B.S to have the number 5 in it? Or do you expect it only for A? So I guess in chat, say only A, or both A and B? Let's get 3 answers in chat. What you think it should be. Is it only going to show up for A, or is it going to show up for both of them? Right, so I appended 5 to A.S. And now I'm checking what the values are going to be for A and for B. Right, notice I don't do B.S.append 5. Andrew says both. Jonathan says only A. Let's get a third answer to break the tie. Right, we have 1 for each side right now. Even if you don't know, it's completely fine to make a guess. 50-50, flip a coin. But I want to get at least 1 more person to break the tie, because right now we have 1 on both camps. How about Alex? Feel free, you can make a guess if you want, but do you think it's going to show up for both A and for B, or only A?
I'm pretty sure it's only B.
Only B. Okay. So if let's check. I think, did I already run this? Yeah, I already ran this. So let me do the displays. Right. So here we go. The answer is it shows up for both. Right. So that was looking at chat. Andrew, you got it right. Both the S for A and the S for B, they're 5. They have 5 inside the list now, right? So notice what I'm doing here is I'm doing A.display, and then I create like a dashed line to separate it, and then I do B.display. So this is the stuff for A, this is the stuff for B. And notice.
I saw it a little wrong on my screen, because I thought it was like one of those things where if you do another line of code, then it like I don't know, it just doesn't run the first one. I don't know. I remember that there's a code for that.
I'm not, it doesn't sound too familiar to me. But if you have questions later, feel free to reach out as well. But in this case, the reason why it shows up for both A and for B, for both of them, is because it's a static variable. It's shared across the instances. And it's static because we defined it this way. We defined it outside of the constructor. And so what this means is there's 1 S field for the 2 objects. They have the same S. And so if we append 5 using A, the B's S is also going to have 5 in it because it's the same one. They share it. Right? And so that's why if I only do A.S.append 5, I only do it for A, it still shows up for B. They're like connected by that static variable. On the other hand, for the instance variable, the non-static one, I can do the exact same thing, right? Let's look at A.I. It's empty initially, right? You can see it was empty here and nothing has changed. It's still empty. I'm going to append 10 this time, just a different number, but it's the same thing. I'm appending something to the list. And now if I display for A and I display for B, let's see what happens. Boom. You can see now it's only for A, right? Only A's field has updated. B's has stayed untouched. And that's because it's an instance variable. It's different copies for different objects. So it's just something that you should be careful of. You should be mindful of. Sometimes it doesn't even matter. But for something that's mutable, like a list, it will be important because you might accidentally modify a different object by working with, like if you're working with one object, you might accidentally mess with someone else's object. And you want to be careful with that. And so generally, most of the fields, the properties that we've talked about are all going to be instance variables. They're going to be declared this way. In the constructor, self dot the variable name equals the value, right? That's typically how you're going to define your fields because they're typically going to be instance fields for now. Yeah. So I know static, non-static, this is definitely not an easy topic. So I really want to make sure, does anyone want me to go over what just happened again? Like why did appending to A have it also show up for B in this case, but then in this one, it only shows up for A and it doesn't show up for B? Like why are these different? Does anyone want me to go over that again? Yeah, no problem, Jonathan. So the important thing is this code right here, when I'm doing the appending and displaying, this is a distraction. The code here for the first and the second one, they're essentially the same. There's no difference here. The difference is in how we define S and I. We define S here. Outside of any methods, outside of any functions, we just say S equals an empty list. Right? On the other hand, I is defined inside the constructor, and we say self.I equals value, which is taken in from the constructor, right? And so that was given here, right? So when we created the two objects, we gave an empty list as this val, right? And so that's the important thing to keep track of. This S is defined this way, I is defined this way. Because they're defined differently, they behave differently as well. So let me also pull up maybe Paint really quick and bear with me because I'm on a laptop with a touchpad, but I'm gonna make a diagram right here. This is our class, right? So let me make this bigger. So this is our class right here, right? It's like defines everything in our class. It has our methods, whatever. And then using this class, we create two objects, right? So let me, we have A and we have B, right? These are two different objects. This is B and this one is A, right? They were defined from this class, right? So they're like, how they work is all from the class definition. They're just specific objects. And the difference between the variable S and the variable I is that S belongs up here in the class. It's shared, right? There's one copy for the both of them. On the other hand, oh God, writing is bad. On the other hand, both A and B have their own version of I because it's an instance variable, because it's an instance field. So both A and B have their own copies of I, but they share the same copy of S. So that's what it means to be static versus instance. When something's instance, each single object has its own copy. It's like you're duplicating it every time you're creating an object. You make a new version of it, and it's completely disconnected from other versions that you already have. Static variables, on the other hand, are not like that. They are shared. You have one version, one copy, you don't get any more. That's it. That's all you have, one copy. Right? So if we look back here, keeping that in mind, hopefully it's a little bit more clear. Here, when we append 5 to this static variable, because it's shared, it shows up in both A and B, right? It's shared. So if you append to one, it shows up in the other. You can also think of it like they're linked. On the other hand, this variable I is an instance variable. Each object has its own copy. And so when we append 10 to I, it's an instance. It's only A gets it because A has a different copy from B. They're separate lists. Right? So shared, separate. Right? Static, non-static. Shared, not shared. I think the easier thing to remember is static versus non-static means shared versus not shared. You can think of static like shared. Yeah. The harder part is remembering the Python, like how you do it in the Python itself. This is a static variable. And this is an instance variable or non-static. Okay. So you can see that they look different in the class definition, right? Like we're not saying I equals val. We're saying self.I equals val. The other way you can kind of tell this already is notice like this I needs a self associated with it, right? It needs a specific object. Self is just an object. And so you need a specific object to access this I thing, which shows you that each object has its own I, right? Because depending on what self is, you have a different I. Right? Like if self is A, then you have one version of I. If self is B, you have a different version. On the other hand, S is just S, right? Whether it's A, whether it's B, it's S the same. Did that help a little bit, Jonathan? Or is there something that's still catching? Okay. I'm glad that helped. Let's check on time. Doing well on time. Really quickly, I don't want to see anyone else have any details that you want me to go over again about this whole static, non-static, as well as just what we covered in review as well. Just classes in general, what we've talked about classes, fields, methods, self, something like that. All right. Well, I'm gonna go back to the slideshow and go to the next slide. I'm gonna start the kind of new topic. And if any questions do come up about the old topic, still feel free to message in chat. But the new topic is talking about inheritance. And so you might have heard inheritance from just like if you've taken biology or know how things are passed down from your parents, like your genes. That's the same idea for Python classes. How you can have a parent and a child, and the child will inherit some properties of the parent. It'll be similar to the parent, but maybe it has some new stuff, unique things that's specific to the child, right? That idea is in Python in classes, in the idea of inheritance. And basically it allows you to be lazy, which is what we love being as programmers. We love being lazy. And so inheritance is the idea of taking a class that already exists. Maybe you wrote it or someone else wrote it, whatever, it already exists. And you create a class that's based off of that one that maybe has some extra things, extra bells and whistles attached to it. Or maybe it has some slightly different behavior. But the idea is you're basing like a big part of the class on something that already exists. You're not reinventing the wheel, right? So if you have two classes that need to do similar things, instead of writing the same functions, the same fields over and over again in the two different classes, you just have an inheritance structure where you have one version that has all the shared things, and then you have different children that inherit and do the unique things that the children need to do. And so again, inheritance allows us to define a class that inherits all methods and properties from another class. So we just said methods and properties, that's everything a class has. So what this means is a child class will inherit everything from the parent, right? Pretty much without restriction. So anything that the parent can do, the child can also do, right? Anything the parent knows, anything the parent has stored, the child also stores it. Okay? And so the terminology here is you have your parent and you have your child, or you have your base class and your derived class. I'm going to stick with the parent-child terminology because I think it makes sense with this whole inheritance idea. You have your parent that passes on things to the child. And so what does that look like in Python? It looks like this. So there's a lot of code on this slide, I'll admit that, but don't be scared. So Andrew, I see your question. That's a really great question. The answer quickly is yes, but we're actually going to talk about that in depth later on. A child can have as many parents as you want. And Jonathan, you're kind of just copy and pasting. Yeah, that's a great way of thinking of it, actually. You are basically just copy pasting. If you think about it, actually, a lot of the stuff that we've covered in Python 2, you can say it's basically copy pasting, right? When we define functions, all we're doing is defining a block of code that we can use in different places. It's basically just copy pasting those lines of code in different places. The reason why we have all these things and not just copy paste is for a couple of reasons. Andrew, what you said is correct. You can basically make some modifications as you're pasting, in the sense that it's not just an exact copy, but it has some extra things or some modified things. So you're basically taking like a shortcut. Another reason why you don't want to copy paste, and hopefully something I've mentioned before and is in your head, is that when you copy paste, it's very easy to make mistakes. If you copy paste some code and you realize the original has a mistake, then all the copies also have the same mistake. And so if you realize you need to change something in the original, you have to go in all those different places and change the copies as well. But if you have this inheritance structure and realize, oh, hey, the parent has a bug and it doesn't really work how I want it to, I just change the parent and the child automatically gets the new version, because what it's doing is it's inheriting. And so if you change the parent, it also changes the child. But if you were copy pasting instead, if you change the parent, then the copy is just, the child's just separate and you have to change the child as well. It's just more work for you. And so that's why inheritance is useful. But I really like what's been going on in chat. It's kind of just copy pasting. It's like, yeah. So if we look at the code here, this first thing, this class parent, this is very similar to what we talked about last week. Right? This is just a class. You have a static field right here, age equals 40. And then you have a couple of functions. They don't really do much. All they are print statements, but they are functions. You have your constructor, and it prints out this statement thing. You have parent method, you have set age, and you have get age, right? So this is a parent class. Then what inheritance looks like is right here. This is the new thing that you should focus on. The first line is where we do the inheriting. And if you notice, it looks different, right? You have your class and your class name like before, but now you have parentheses. It's almost like a function where you have your parameters, your inputs, You can think of inheriting as like inputs to the class, right? When you're defining the class, you need some other class as input because that's what you're inheriting from. You're telling, hey, look at this place for fields and methods that you're going to copy into here as well. And so you put that into parentheses. And here we say we're inheriting from the parent class. You put the name of the class that you're inheriting from inside the parentheses. Otherwise, it's the same, right? You have your class name, you have your colon, and the functions are not even different either. You have your constructor here, you have your child method here. But the special thing is that in this child class, you have access to the age. You have access to all these other methods. So to show that, I'm gonna hopefully copy and paste that into here, and let me pull it into here as well. I have some examples prepared as well, but let me just do this one. Hopefully it pastes in nicely. I know sometimes copy pasting isn't very well behaved. But here we go. Okay, so I have my classes defined in my notebook now. Let me create a parent. So like P equals parent. And if we look at the constructor, it does not take in anything, right? Notice you can ignore the self because that's supplied automatically. It doesn't take anything else. So I just say parent with nothing. And so when I run this, it says calling the parent constructor. And I can access some of the different methods like p.parent method. And it will say calling parent method. I can do p.getAge. Oops. And I'll say parent attribute 40 because it's doing this thing. And now let me create a child object, right? So C equal child. And if I look at the constructor, oh, okay, this one also doesn't take in anything, right? So let me do this and notice it says calling child constructor because it's a different constructor. It's a different class, different constructor. It does something different. And so I do calling child constructor, and let me just call the child method, right? C.child method. And it will say calling child method. No surprises here, nothing. We haven't really seen the power of inheritance just yet. But the magic now is that with this child object, we can also get age, set age, parent method, right? We can do C.getAge, and it will get the age and it'll say it's 40, right? We can do C.setAge. Let's set the age to 8 because that's more fitting for a child, right? And we have to print it again, C.getAge. And you can see, hey, it changed the age to 8, right? Not much of a surprise there. And so this kind of begins to show the power of inheritance. Look at this child class, right? Look how short it is. Look how small it is. All we are doing is defining a constructor, defining one method. But look at what we have access to. We have access to get age, set age. We can even do C.parent method. Right? We have access to all these things because of inheritance. Like Jonathan said, it's almost like we took these methods and copy pasted them into the child, right? It's almost like that. That's basically what inheritance is doing. It's just taking those things, putting it inside the child class. Right? So I have another example here. I defined my class animal, and the constructor takes in a name and then stores it into a field. And then I have a speak method and I have a get name method. And so I can create an animal and I'll say the name is Jack, and I can do a.speak. And it will say I am Jack. I can also define a subclass, a child class that does inheritance. So I can define a class dog that inherits from animal. And I have my own constructor. You can ignore what it's doing now, but it takes in a name, breed, and age. And now I also define my own speak. And since it's a dog, the speaking should do bark, right? And so I create my own dog. It's called Spot. It's a golden retriever and it's 5 years old. If I do d.speak, it does bark, right? It's inheritance. This one is not really as interesting, but it does have something new that I want to talk about as well. The idea here is I'm doing something called overriding a method. Because, for example, if I take this speak method and I comment it out, so I remove it from this dog class, I commented this out, can I still do d.speak? Yes or no in chat. Can I still do d.speak here if I comment this out? I removed it from the dog class. Can I still do this? Andrew says yes. Jonathan says yep. So Andrew or Jonathan, why yes? Why can we still do it? We removed it from the dog class, right? We commented it out. It's no longer here. Why can we still do the speak method? It's the correct answer. You can still call this speak method, but why? The parent class has the speak function. Exactly, right? This dog class inherits from animal. An animal has a speak, right? So even if I didn't define it here, it automatically has a speak method. And so here, if I do d.speak, it's not going to say bark. It's going to say, hi, I am Spot. Right? That's what the dog is called. Okay. So if we look at this, this is pretty interesting because we already have a speak method. It already does something. But when we define it here, we kind of change how the speak method works, right? This is called method overriding. You're overriding some existing behavior, right? So overriding, if you don't know what that means, it's like you're covering it up, you're updating it with something else. You're like, this is okay, you already do that, but no, do this instead. You're just overriding it. And so that's what's going on here. There is a speak method from the animal class, and it says, I am whatever the name is. But I define my own speak method, right? Notice it looks the exact same. Def speak self, def speak self. It's the exact same. It has to be the exact same to do overriding. Because what you're doing is, instead of doing the speak from the parent, I have my own speak. I'm overriding the parent. And this allows you to basically define new behavior for your child class. I think that's all I wanted to say about method overriding. Again, it's useful in some cases. This is a really dumb example, so it doesn't really look useful here, but the idea is very important. And let me just show it here. I redefine it here. And if I do speak, now it does bark. Right? And just redefine what this thing should do. I guess one final note is, notice that when you call a function, there's kind of like two versions of this function that's possible, right? There's the version here in the dog class, and there's a version here in the animal class. The reason why overriding works is because Python, and pretty much any language that does inheritance, prefers the child's class over the parent class. It prefers the more specific, the deeper class than the more general, the broader class, which should make sense. And so when we say d.speak, Python goes, hey, the animal has a speak method. The dog has a speak method. Which one do I pick? I pick the child one. I prefer the child one if there's a tie. And so that's why it does this bark instead of I am Spot. This is kind of behind the scenes why method overriding works. And let me just go back to the slides, make sure I'm not missing anything. All right. The last thing before going to homework and finishing class is this kind of corner case, only useful in one place, but it is useful. This idea of this super function. And so this slide says the super method, it's just a method, it's just a function. And it returns what's called a proxy object or a temporary object, kind of like a fake object of the superclass that allows you to access methods of the parent class. And so what this looks like is here. So this is a different dog class. And here, this is the dog class, it inherits from the Canidae family. And in the constructor, I have super dot init dog. And what happens here is we said that the super function, what it does is it gets you like a fake object of the parent class. So it basically gives you a Canidae family object, or it's accessing things from the Canidae family. And so when I do super dot init, I'm not doing this init function. If I were, it'd be like an infinite loop, right? If I'm calling myself with no end, that'd be an infinite loop, infinite recursion. What I'm doing here is not my own init, I'm doing my parent's init function. And presumably it would take in a string, right? And if we look at the code I have, that's what I'm doing here. In the dog constructor, what I'm doing is I'm doing super, which gets me like the animal class. And I'm calling the animal class's constructor, which if we look up here, takes in a name. And so I pass in the name here. And so what this is doing is basically running this. It's almost like copy paste again, right? I can copy this and replace it with this line, right? It's essentially doing the same thing. Right? So super is pretty much only used in the constructor, or at least from what I see, I only really see it in the constructor. And it's just used to access the parent's methods. The most common case is just in the constructor accessing the parent constructor. You can use it here as well. So you can say super dot bark. Oh no, get name. Speak, my bad. So if we do this and now do d.speak, notice when I do super.speak, it gets the parent class's speak method, right? I'm saying explicitly, hey, go super, go up, which is my parent. So get my parent, get its speak method, not mine, get the parent's speak method and do that. And so that's why it does I'm spot, because that's what the parent method is doing. And then I do my own thing, I print bar, right? So you can use super anywhere in the class. It will get this parent, but most typically it's in the constructor calling the parent constructor. Okay. Now, and in case you are wondering, if you have multiple parents, it looks like this. So this dog class, so many dog classes, sorry about that. But this dog class inherits from two different classes, non-marine mammal class and non-winged mammal class. And what happens here is it does what you might imagine. It just inherits the properties and methods from both of those places. It's like a, I don't know, it's just being greedy and taking everything from everywhere, right? And when you do super in this case, essentially what happens when you do super.init is it does it for both parents, right? So the super, since you have multiple parents, it kind of does it for each parent. Right? Otherwise, this multiple inheritance idea, inheriting from multiple different classes, it works exactly the same as a single inheritance structure. I know I'm at 7 o'clock, so I'm going to end it off with the homework. The homework for this week, like last, it's a little bit more creative. If you have finished last week's homework, first of all, please submit it so I can take a look. Although from what I've seen, it looks good. I want you to create a parent-child class structure. So practice doing inheritance. So I want you to have a parent class and then have, and it says the class should have at least 3 attributes, 3 methods. And then you should have a child class, which derives from it or inherits from that original class. And in the derived class, in the child class, you should override a method and you should add some more attributes, some more methods. And then not just define this, but you should also like play around with it. You should test it out after you've created that. But that's the homework, practicing inheritance. For example, you can create a vehicle class as your parent, and maybe that has like number of wheels, maybe has the weight, maybe it has the color. And then you have your truck class that has maybe like a method that like unloads the pickup in the back. You can imagine it's a pickup truck. You can have a method like honk that maybe overrides the truck's honk method. Maybe the vehicle's honk method. Maybe the vehicle honk does one thing, but the truck honk does a different thing. Who knows, right? Maybe it prints different things. It's completely up to you. But I know it's 7:03. I went a little bit over, so I'll stop now. If anyone has any questions, I'll be sticking around to help answer. Otherwise, have a great week, and I'll see you next Monday.